class. This is a week 4 video, part 1, on the fundamental theorem of calculus, which, as its name suggests, is very important to the study of calculus. The fundamental theorem of calculus is basically the idea that derivatives and integrals are inverses. This is something we've discussed already, but derivatives and integrals are inverse processes and they undo each other. There are several versions of the FTC, or the fundamental theorem of calculus. There is a version for indefinite integrals. Indefinite, remember, meaning that there are no bounds. So if I have the integral of g prime of x dx, well, the integral of g prime, those two undo each other. This is simply g of x, but it's indefinite, so plus c, a constant of integration. We could also have a definite integral. So using the same g prime of x as my integrand, integral from a to b of g prime of x dx. Just like before, we'd take the integral of g prime, those undo each other, we get g of x, but evaluated from a to b. And then to evaluate, we plug in b and a and subtract, and we get g of b minus g of a. So that's the definite version. Instead of using g prime as my integrand, I can also use a different function, and so I'm going to call this big F notation. So we can look at the FTC with big F notation. So if big F prime of x equals the function f of x, this means that big F of x is the antiderivative of little f of x. So the derivative of big F is little f, and the antiderivative of little f is big F. So if big F prime, the derivative of big F is little f, then the fundamental theorem of calculus tells us that the integral from a to b of f of x dx equals big F of x evaluated from a to b, which is big F of b minus big F of a. So we're going to explore this a little bit. So we're going to look at this same theorem, and we are going to, so this is version 1 of the fundamental theorem. Version 2 is going to be the other fundamental theorem. It's kind of the same idea though. So let's say we had d dx, so the derivative of the integral from 0 to x of f of t dt. So the fundamental theorem should tell us that derivatives and integrals undo each other. So the answer here is that the derivative and the integral undoes each other. X gets plugged in, and this results in f of x. There is no plus c because this is a definite integral. So we're actually going to work it out we're going to work out how to do this problem. So we started with the derivative of the integral from 0 to x of f of t dt. So I'm not going to take a derivative yet. d dx is going to hang out front. I'm just going to do this inside part, but we already know that the integral of little f is big F. So this is going to be big F of x, or excuse me, of t, evaluated from 0 to x. Still haven't taken a derivative. This becomes the derivative of big F, now I'm going to plug in, of x minus big F of 0. Well, big F of x is a function, and big F of 0 is a number. So now I'm actually going to take the derivative here. So the derivative of big F of x is big F prime of x minus the derivative of a number is 0. But wait a minute. Big F prime of x, we were told that big F prime is little f. This is little f of x, which is what we said the answer to this problem was in the first place. The derivative of the integral from 0 to x of f of t dt is f of x. Same function. There's also a chain rule version. The chain rule version would be something like the derivative of the integral from a, which is any number, to g of x, which is a function, of f of t dt. Okay, so what happens here is pretty similar. The derivative and the integral cancel out. The bound that is a function gets plugged in, but then we have to account for the chain rule. So what we wind up with is f of g of x times g prime of x. You have to multiply by the derivative of the bound after you plug it in. So now would be a good time for y'all to pause the video and try to work this out like we did above, doing the derivative so you can see where that g prime of x comes from. Try to pause the video and work it out. Okay. So we're going to move on from there, and we're going to do an example. You should have this formula written down. If you don't, you need to pause and write it down. But let's do an example of the second fundamental theorem here. Okay, so example 1. Got the derivative of the integral from 2 to x of the square root of 1 plus t squared dt. Okay, I see the derivative and the integral. The derivative and the integral cancel out. Now, all I have to do is take the bound and plug it in. And so my answer is going to be the square root of 1 plus, it's not t anymore, it's x squared, times the derivative of x, which is 1, so I don't need that. And that is the answer. Letter C. So now I have an example 2, which is a you-try problem. So go ahead and try this problem. Pause the video to work it out. You're doing big F of x is the integral from 1 to x squared of the square root of 1 plus t cubed dt. And you're finding f prime of x. You're taking a derivative here. By this point, you should have paused the video to try to work out this problem. We're going to do it together now. So this is big F of x. I need big F prime. which means I need to take a derivative. I'm going to be taking the derivative of the integral from 1 to x squared of the square root of 1 plus t cubed. Derivative and integral cancel out. X squared, the bound, is going to plug in, sorry, there's a dt here, is going to plug in for t. So we're going to get the square root of 1 plus, now it's not t anymore, it's x squared cubed. But this is a chain rule. I have to do times the derivative of x squared, which is 2x. Okay, so that should help me find my answer. I've got this 2x here, and x squared cubed is going to be x to the 6th power. So I'm going to have 2x root 1 plus x to the 6th, and that is letter A. So you'll have an assignment, a short assignment like this on the second fundamental theorem. That's when you're taking derivatives of integrals. But now we're going to go back to the first fundamental theorem, and we're going to do another example. Okay, example 2. We've got a graph of f prime here. The figure above shows graph of f prime, the derivative of a twice differentiable function f on the interval -3 to 4. Okay, I see that. The graph of f prime has horizontal tangents at -1, 1, and 3. Okay, so that just means that f prime has a min, a max, and a min right there. The areas, ooh, that's good. The areas of the regions bounded by the x-axis of f prime from -2 to 1 and 1 to 4 are 9 and 12 respectively. So they didn't give me signs. They just told me that this area here, that area is 9. And this area here, and that part is 12. Okay. Given that f of 1 equals 3, write an expression for f of x that involves an integral. Then find f of 4 and f of -2. Okay, so this is going to be the fundamental theorem of calculus, and I am going to need the fact that the integral from a to b of f prime of x dx, so I started with f prime, that equals f of b minus f of a. But we're actually going to rearrange this a little bit. We're going to take this initial condition and we're going to add it over to the other side. So we're going to get that f of b is equal to f of a plus the integral from a to b of f prime of x dx. Okay, so they gave us an initial condition. So this 1 is a, and this 3, that's the y value, that's f of a. Okay, so if I want an expression for f of x involving an integral and f prime, I can say that f of x equals my starting value 3 plus the integral from where I started to, look at this, so x is going to be your b value, to x of what graph am I integrating? F prime. F prime of, we're going to use the dummy variable t, d, t. That's my expression for f of x that involves an integral. Now I have to find f of 4 and f of -2. Okay, so f of 4. F of 4. Everywhere I see x, I will be plugging in 4. So f of 4 equals 3 plus the integral from 1 to 4 of f prime of x dx, or f prime of t dt. It doesn't matter, it's a dummy. Okay, so what I've got here is 3 plus the integral from 1 to 4. Well, the integral is an area. I'm starting at 1. I'm starting at 1 and I'm going to the right. But this is below the x-axis, so that's going to be a negative area. This is -12 here. This is going to be 3 minus 12, and my answer is -9. Next, they want me to find f of -2. So that's going to be 3 plus the integral from 1 to -2 of f prime of t dt, or x dx. Okay, so now I'm going from 1 back to -2. Well, I'm going backwards now. We're going backwards, we're in opposite land. This is going to be a positive value. So I'm going to wind up with 3 plus 9, which is 12. And those are my answers there. Okay, so now you try it. Now you try it. So I'm going to leave the video right there. You should pause it at this point. We've got a graph of f prime, and we've got that f of -2 equals 7. So you should pause your video, and you should work out this problem. So hopefully by now you've paused your video. I'm going to give you a few tips before revealing the final answer. So if you need just a little hint to keep going, you can keep listening here. One tip I would have is to mark your starting point. So my starting point is at x equals -2. So here's -2 on the x-axis. I'm going to mark that starting point, and I'm going to shade and sign my areas. So starting from -2, going forward, this area here is negative. This area here is positive. If I'm going backwards, we're at opposites. So this area backwards above the x-axis is actually going to be negative. So you should continue working out the problem. Make sure you write an expression for f of x. I'm going to reveal the answers after this pause. So hopefully by now you had paused the video and you had worked out your answers. This is how you would work out the answers. You want to write an expression for f of x that includes your starting y value plus the integral from your starting location, -2 to x. Plug in whatever value they want you to for x. You'll need to find the areas that we had signed, and I'll give you your answer. So that concludes the lesson on the fundamental theorem of calculus. Please look for the assignment on Google Classroom. Thank you for watching.